We're going to start on section 18.1. What we've done so far in this chapter is 18.0 assignment, which was really mostly just review of 30, 60, 90, 45, 45, 90 triangles. Now we're going to be dealing with degrees on a circle, and the ones we really care about are the 30, 60, 90, and 45 degree angles. We will be doing some of the ones in between as well, but those are the most important ones. Those are the ones I kind of want you to memorize. If this wasn't the year of online instruction, we would have quizzes where you'd have to memorize all the numbers related to these circles in degrees, in radians, the sine and cosine that go with each of those angles. You're talking about memorizing sine and cosine instead of just using your sine and cosine tangent buttons on your calculator. We'll have some problems in this chapter where we have to do that. We're going to do section 18.1, 18.2. Because we're doing online this year, I think we're skipping 18.4. We always skip 18.3 because that's an honors topic. So let's see what we have here. Let's start with what you remember from before. I think that from last year, maybe the year before, you remember that a circle has 360 degrees. Well, we're always going to be working with starting our angles right here. This is our initial side. The positive part of the x-axis is our initial side, our starting side. And then we're going to go around the circle. So this is going to be 0 degrees right here. And we're going upward. And some of you may have wondered when you first learned about quadrants, how come it goes 1, 2, 3, 4 in that direction that feels backwards? It's so that your angles can go up first and go around this. So when we have a positive angle, we're always going to be going up. I'll put that in writing on the next slide. But we'll say a full circle is 360. So if this is 0, and we went all the way around the circle and came back to the same place, we'd have 360 degrees. And people might be tempted to say, since those are in the same place, 0 degrees equals 360 degrees, but that is definitely not true. They're in the same place, which is what we call coterminal. And I sometimes use like a similar symbol here. But I wouldn't put equals because 0 degrees is not equal to 360 degrees. I changed that initial rate of black instead of red because I'm going to use different colors to mean different things throughout this chapter. So if I go 0, 360, I could say, what if I took 360 divided by 2? That'd be 180 degrees. 180 degrees. But I think you remember from last year that a straight angle, an angle that goes straight out, its beginning and its ending rays form a straight line, is 180 degrees. If I took 180 degrees and did that divided by 2, I'd have 90 degrees. So up here, 90 degrees. If I go around my circle, I can say 90 degrees plus 90 degrees is 180, plus another 90 degrees is 270 degrees, plus another 90 degrees takes me back to 360 degrees. And then I need to split that up and have numbers on all of those other lines. I'm going to start here with, what if I took my 90 and divided that in half? And I'd have 45 degrees. So I'm going to have 45 degrees here. And if I add 45 degrees plus 45 degrees, I get to that 90 degrees. Plus another 45 degrees takes me to 135 degrees. Plus another 45 degrees takes me to 180 degrees. Plus another 45 degrees will take me to 225 degrees. At some point you might start wanting using your calculator to figure them out, but I hope that by the time we finish this chapter you have them memorized. 270 degrees plus 45 degrees takes me to 315 degrees. And if I add 45 degrees again, I get up to 360. That's each quadrant. Remember, these quadrants are 1/4 of the circle. Each quadrant has now been cut in half. I want to now say, what if I took the quadrants and cut them into thirds instead? A 90-degree quadrant cut into thirds. And I'm going to be switching back and forth between blue and green, which right now, why I switch back and forth is not going to make a lot of sense. But throughout the chapter, we're going to use the same blue. I'm going to always use the same red, blue, and green. If you want to use 3 different colors for your notes when you're writing it out yourself, that's great. But you don't have to. I'm just going to be consistent, and you'll see the patterns as we go through. So I'm going to take my 90-degree quadrant. I'm going to divide it into 3 parts. And this is 3 parts if I ignore the middle part. Can you see that they're equal parts from there on? For each of these sections, I'm just going to ignore the middle part for now. And I'll come back and look at it later. But I'll just say, forget that. We're going to go around the circle in 30-degree sections. When I write close to the edge, it wants to jump. Go around the circle in 30-degree sections. So 0 plus 30 is definitely 30 degrees. And if I do plus 30 again, I'll get to 60 degrees. And plus 30 again takes me to this 90 that I already know. And plus 30 again takes me to 120 degrees. Plus 30 again takes me to 150 degrees. Plus 30 again takes me to that 180 that I already know. Plus 30 again takes me to 210 degrees. I think I want that one to be green. 210 degrees plus 30 degrees again takes me to 240 degrees. Plus 30 degrees again takes me to the 270 I already know. Plus 30 degrees again takes me to 300 degrees. Plus 30 degrees again takes me to 330 degrees. Plus 30 degrees again takes me to the 360 degrees I already know. Those measurements, I hope you will start to memorize them so that you don't have to look at the circle every single time you need to work this out. Everything gets quicker if you can memorize some things. I copied those angles on the next page so that I don't have to work with them again. We're going to take and use those numbers as a guideline to draw some angles ourselves. We will always be using, as I was just talking about in the last section, our initial side is going to be on the positive part of the x-axis. So I'm going to go right here and I'm going to draw the initial side. And you might look at it and say, there's already an arrow there. What do I need to draw one for? That one's the axis. You need to draw in the initial side. And I'm just going to draw it on every one of these before I start because it'll make it easier to see what's going on. I think there are only 2 problems in the 18.1a assignment where you have to draw the angles yourself. And then there are a lot more of them in the 18.1b and beyond that. But they'll always start right there. If it is a positive angle, it's going to start here and it's going to go up. If it is a negative angle, it's going to start here and it's going to go down. The starting side is called the initial side. The ending side is called the terminal side. So I'm going to draw 150 degrees. I could just look up here and say, oh, there's where 150 degrees is. Let me draw it. But let me talk about if you didn't have the circle in front of you. If you didn't have the circle in front of you, you would start out by thinking about what's going on. Here's my 0 degrees. Half a circle is 180 degrees. All the way back to the beginning again is 360 degrees. 150 degrees. It's less than 180. So I'm going to start going upward from here because it's positive. And I'm going to go around. And if I went all the way over to here, that would be too far because that's 180 degrees. So I need to back it up a little bit and say, where exactly am I going to? If I went straight through the center here, that'd be 45 degrees. That would be this 90 degrees plus another 45 degrees. Would that be 150 yet? Not yet. I need to go farther than that. I need to think of this as 90 plus what? 150. If I've already drawn 90 of it, yeah, right to there, I've drawn 90 of it. I want to know how much is left that I have to draw. I have to draw another 60 degrees left to draw. This is part that's done, and this is what I have left to draw. You do not have to show me those subtractions on paper, but I have to say I need another 60. If we look back to the beginning of this, we can see 60 degrees is 2/3 of a quadrant. So I need to draw another 60 degrees past that center line, right around there somewhere. Now that black line that I put in there, I really don't need that guy. Even though he was a dotted line, he was maybe confusing me, so I took him out of there to say I need to be about 2/3 of the way over there. Is that perfect? I don't think it matches perfectly with this 150 up here, but about 1/3 of the way away from here. And 1/3 of the quadrant is 30 degrees. So I would say that this one has the terminal side, which means the end, is 30 degrees from the negative part of the x-axis. Now, when you draw your picture, I would like to have you label either how far is it from the x-axis or how far is it from the y-axis. But since later it will be the x-axis that we have to do, that's usually what I'm going to be drawing. Sometimes I'll put in both. Let's try 300 degrees. Again, 300 degrees, it's on my circle that I already have, but I'm going to think it through instead, because you may not always have that circle in front of you. I'm going to say start with 0 degrees, go over to 180 degrees, and continue on around till you get to 360 degrees. I always put that down first, even though it's not required. I need to think about drawing my angle, which is just a big arc. I already have my starting side, and I'm going to say 90, plus 90 is 180, plus another 90 is 270. Let's get that smoothed out. But I need more than that. So I have 360 degrees. I've already drawn 270 of that. That leaves me with how much left to go? I don't want 360. I actually want 300. So I want 300 degrees. And I've already done 270 of that. That leaves me with another 30 degrees left. So this is what I want. This is what's done. This is what is left to draw. Again, that's just so I can show you what I'm doing. It's not required. So I'm going to say I got to keep on going around here another 30 degrees, and 30 degrees is 1/3 of a quadrant. So that I end up with 30 degrees away from the y-axis, which leaves me with an extra 60 degrees here. The actual measurement of this angle, if you were labeling the measurement of the angle, 300 degrees, but I'm not going to worry about that when that's up there, But I'm going to write down that this ends up with its terminal side is 60 degrees from the positive side of the x-axis. And it really doesn't matter if it's up or if it's down as far as making a statement, because later when they ask us to find the reference angle, we'll always say it as a positive, whether it's up or whether it's down. But you might, if you were describing to someone what it looked like, you would want to say it was 60 degrees down from the x-axis. Or this one over here in the beginning was 30 degrees up from the x-axis. Next one we want to do is 710. For the ones that we already did, 150 degrees, we found it. 300 degrees, we found it. We're now trying to say, what about 710 degrees? That's more than a full circle. So I'm going to start at my initial ray, start on the positive part of the x-axis. Think about 0 degrees, 180 degrees, 360 degrees. But we're going to have to go past that. So I'm going to think about starting here, going around the circle. Don't end up in the same place because we got to continue our spiral. We're really talking about something like around and around some more. So we're going to have a big spiral going on here. Not just a simple arc, but a big spiral going on here. How much further do I have to go? Let me think about something. If I want 710, and I've already drawn 360, that leaves me 350 left to go. Gives me almost a full circle more. So I'm going to pick up where I left off. I'm going to keep on going around. If I went all the way to here, I'd be at 360 plus 360 is 720. I don't want 720. So I'm going to have to take it back a little bit. Really just a little bit. Because how far back do I have to go? A full circle would be 360, but I only want 350. So I'm going to take it a little bit back from there. And the amount that it's back is just 10 degrees away. I think that's so small, I'm not sure you can read it. But it's 10 degrees away. So if I wanted to describe this, I would say the terminal side is 10 degrees from the positive side of the x-axis. When I start writing in the border, I don't know if you can see it well. Okay. What's the next one? Negative. We got a negative angle to deal with. I'm still going to think about 0 degrees, 180 degrees, 360 degrees. But maybe, now that I want to do a negative angle, which means I need to go down from here instead of up from here, maybe I want to think of this as going backwards, negative 180 degrees. And if I went all the way around, I'd be at negative 360 degrees. So if I just wanted to switch this a little bit because I'm thinking about going the other direction, I could say negative 360 degrees and 0 degrees. There's no such thing as negative 0. I put an arrow on here, but I don't really need an arrow on there yet because I don't know where I'm going. I know I'm going here, and I know that I'm going more than 90. I'm going negative 225. Let's go look at the original circle and say, if I was trying to go to 225 degrees, starting at 0, I would say that is a quadrant plus a half a quadrant. I need to now take this thing the opposite direction, which is start going downwards, a quadrant plus a quadrant plus a half a quadrant. That's where I need to be to get what I want for this problem. So a quadrant and a quadrant and half of a quadrant. So I'm going to finish this off here. And yeah, I'm putting a lot of arrows in and I need them. I want to see the arrows for the beginning ray, the ending ray, and the arc that goes around the circle. Negative 225 degrees. Now that's all that's already there, and that's all that's in the typed notes, but I'm feeling like I want to do another example. I'm going to do negative 140 degrees, because every one example that's already there was one that I could see easily on the news. I'm still going to have to do my starting ray. Even though there's an arrow already drawn, I make an arrow on top that's clearly dark enough to see. If you're drawing them yourself, you just got to make them darker than your things you did in the first place. I need to go in the negative direction, so I need to go down instead of up. If I'm thinking about 0 degrees and 180 degrees, but I'm going in the negative direction, so I may want to throw a negative 180 degrees on there. If I made my curve go all the way to here, too far. So let's try and take that back a bit and think about what exactly I do need. If I have, I'm drawing in the negative direction, if I've got negative 140 degrees, and I already drew in there 90 degrees worth, that leaves me another 50 degrees left to go in the negative direction. So if I went to the exact center, that'd be half of a quadrant. Half of 90 is 90 degrees. I don't want that. I want to go a little bit more than halfway over. A little bit more than halfway over. I'm not expecting perfection, but I'm not going to be happy if you draw that line and you put it, said, oh, more than half. So suppose you put it right here. Yeah, more than half. No, that's not more than half. It is more than half, but it's way more than half. I need to be barely more than half. If I draw this half line, yeah, right around there somewhere, that's what I'm looking for. Get rid of all those green lines. Those are not really what I want. This is the angle I want to see. I wanted you to see one that goes negative and doesn't exactly match. If you look over to the original, you can't see 140 anywhere. You can see 135. And you say, a quadrant, a half a quadrant, but I need a little more than 135. Okay, let me move on and let's look at the next page. This time they're talking about coterminal angles. Coterminal angles means angles that start in the same place, end in the same place, but they might go around the circle more times. If I go back to the page I just left, I want to look at this one down here. Negative 225 degrees. We went quadrant, quadrant, half a quadrant. We ended up in the same place as 135 degrees. That means that this angle, 225 degrees, is coterminal to 135 degrees. And I never wrote down for this one what I wrote for the one over here. So I'm going to also, while I'm here, think about writing the terminal side is, how many degrees is it from the x-axis? It was in the half right there, so it's 45 degrees. 45 degrees from the negative x-axis. And I didn't have to write these words, but I am asking that you write me a number that tells me how far away from the axis it is. That, when I'm talking about that concept coterminal, it was good to come back to this and say, this is in the exact same place as 135 degrees, which means it's coterminal to 135 degrees. I know, my notes are getting long, and I have a part 2 to do too. That's okay. I'm taking plenty of time to explain it. Sometimes in class, you feel like I rush a little. Here, I'm not rushing. I'm telling you everything I need to know because you can't stop and ask me a question, so I don't know if you're confused. I'm just going to explain and explain and explain, get everything in deal we need to know. So coterminal angles have the same terminal side, the same initial side, and you can get to them by adding or subtracting 360 degrees. We're just going around the circle an extra time around. So 300 degrees. If I wanted to find another one that was in the same place as 300 degrees, but was an extra time around the circle, I could say, let's add 360 to that. 360, that makes it 660 degrees. That's the first answer they're looking for. What that means on the circle is this. If I went to 300 degrees, which is right here, and then I went around the circle one more time. I don't know how to change my highlighter to a different color. Oh well. I went one more time around the circle and ended up in the same place, I would be 660 degrees around the circle, but still ending up in the same place. So, I paused and forgot to restart. So I don't know how far back it was since I last recorded. So let me just talk about what I have in writing here. I have I took 300 degrees and I wanted to find a coterminal angle that was bigger and just went around the circle an extra time. I did plus 360 degrees and got 60 degrees. The easiest way to think of these is just add or subtract 360 degrees. If I wanted to go from there to another one, plus 360 degrees. If I wanted to get one in the negative direction, think about 300 degrees goes like this. I could get there by going another 360 around and ending up at the same place. That's 660. If I went another 360 around and ended up in the same place, that's 1020. If I wanted to find an angle that was the same, again, let's say this is 300 degrees. But a different way to get there would have been to go this direction and end up at the same place. So if I talk about 300 minus 360, I get to negative 60 degrees. And that's what we're talking about here. 60 degrees away from the x-axis, but going in the negative direction. Even more negative, go another time around in the negative direction, negative 420 degrees. I'm going to draw 420 degrees for you. I'm going to start here, draw my initial ray. I want an arrow right there. It is negative, so I'm going to go down. And if I go this way, down, and go full circle around, that is 360. So I have negative 420. I already drew 360, so I need another 60 degrees more in the negative direction. So another 60 degrees is 2/3 of a quadrant. So another 2/3 of a quadrant this way. So if somebody asked you to draw negative 420 degrees, that's what it would look like. It would go around the circle, a full circle, and then continue on past that. Still ends up in exactly the same place as that 300 degrees. What if I started with a negative and I wanted to find a positive coterminal angle, something that ends up in the same place but has a different degree number because it has more circles around? I'm just going to take plus 360 and negative 225 plus 360 gives me 135 degrees. If I go back, we talked about that here. 135 degrees is in the same place as negative 225 degrees. But there are more angles in the same place as that. So I'm going to take that and I'm going to add another 360 degrees. And 135 plus another 360 degrees takes me 495 degrees. That's another good answer for that problem. They want some negative ones, so go back to negative 225. And now I'm going to subtract 360 degrees. Again, notice I might be lazy about putting the degrees in my workspace, but I always put them into my answer. So negative 225 minus 360 would take me to negative 585 degrees. And take that, subtract another 360 degrees, and that would take me to negative 945 degrees. So this kind of problem in our textbook is asking for 4 answers. It's asking for 2 positives and 2 negatives that are coterminal with this. I want to do another example, which is 710 degrees, but this is all that's in your typed notes. I am going to ask that before you watch part 2 of these notes, that you watch this video. I'm going to try and figure out how to add this to the end of the video. I'm not an expert. We'll see what happens. But I'll definitely post this link on School between the 2 videos. Let me go back. If you're done, if you think you got enough, you can quit this video now, but I'm going to explain one more example. 710 degrees. If I wanted to get a positive, I could say plus 360 degrees. And 710 plus 360 is 1070 degrees. And another positive, I could go plus 360 degrees. Gives me 1430. If I wanted some negatives, I could go 710 minus 360 degrees. But I was aiming for negatives and I got a positive. That happened because my starting angle that they gave me was not one between 0 and 360. So now I got 3 positives, and I need 2 negatives and 2 positives. And they want the 2 closest possible. And it looks to me like this and this are closer to 710 than this one is. So even though this is coterminal, it's not what they're actually asking for in the problem. So I'm going to have to get myself 2 negatives by not going back to 710 and doing minus 360. I already did that. I need to go minus 360 from the smallest positive one I know, which gives me negative 10 degrees. And I need another negative, so negative 370 degrees. Wanted to show you one example where just adding twice and subtracting twice doesn't give you what you need. You have to go further. I wouldn't mark it wrong if you put this in there, even though the directions do say the nearest 2, but I would mark it wrong if you don't also get me 2 negatives in there somehow. Okay, I'm going to move on to the next video, but again, I want you to watch this video, which talks about what a radian is, before I start talking to you about how to deal with radians versus degrees.